Now we have the second part of this question. In the previous question, we found the pH of buffered solution of acetic acid and sodium acetate. Right now it says calculate the change in pH that occurs when 0.01 mole solid NaOH is added to 1 liter of buffered solution, which is described in the previous example. Then compare this pH change with that which occurs when 0.01 mole solid NaOH is added to 1 liter of buffer. So we need to see what is the difference in pH change. Let's do the first part for now. So as you remember, in the previous part we had acetic acid, we had acetate, and here we are adding NaOH. NaOH is dissociated completely in the aqueous solution, and of course we have water, which doesn't change anything. So now, since it's dissociated completely, we have OH minus and we have acid here. So we have base and acid, so definitely they react together. OH minus plus HC2H3O2. It's going to give us definitely water plus acetate. So before we have this reaction, number of moles of OH minus will be 0.01. The number of moles of this guy is 0.5, as we saw it in the previous example, 0.5 molar. If we consider 1 liter, it means that we have 0.5 mole. And here, acetate, we have the same thing, 0.5 times 1, it's going to be 0.5. This is ice table. So then we're going to have negative x plus x, and here we have plus x. But right now we know what is going to be the reaction, because 0.01 is base, 0.5 is acid, so definitely acid is going to neutralize this part. So we're going to have 0.01 minus 0.01, 0.5 minus 0.01, and here we have 0.5 plus 0.01. So we have 0, we have 0.49, and we have 0.51 mole. And here, this one is 0. So we're going to have 0.49 mole acetic acid, 0.51 acetate ion. Now, since we added this sodium hydroxide, the equilibrium changes. So we're going to have acetic acid, proton plus acetate. The concentration here is 0.49, 0 or approximately 0, 10 to the power of negative 7, and here you have 0.51. Negative x plus x plus x. So we have 0.49 minus x, 0 plus x, and 0.51 plus x. That's the ice table. So for equilibrium, which is going to be equal to Ka, and Ka is 1.8 times 10 to the power of negative 8, that's for acetic acid, equals to x times 0.51 plus x divided by 0.49 minus x. We can neglect x and x from both sides and have 1.8 times 10 to the power of negative 5 equals to x times 0.51 divided by 0.49. So x will be 1.8 times 10 to the power of negative 5 times 49 divided by 0.49. It's going to give us 1.7294 times 10 to the power of negative 5, and then we have negative log 1.7294 times 10 to the power of negative 5. So pH will be 4.76. So in previous example it was 4.74, so we have 4.76 minus 4.74, so it is increased by 0.02 because of addition of sodium hydroxide. So that's how buffer works. So it's going to resist to pH change. Now let's look at the second part of this example. It says, compare the same thing, the same situation. We add 0.01 mole of solid NaOH added to 1 liter of water, not buffered solution, water. So I'm going to have NaOH 0.01 divided by 1 is going to be 0.01 molar, or 10 to the power of negative 2 mole per liter, which is going to dissociate into hydroxide and sodium. So pH will be Kw divided by, that's actually the concentration of hydrogen. Concentration of hydrogen is going to be Kw divided by OH minus. Kw is negative 10 to the power of negative 14, and this one, the concentration of hydroxide, is 10 to the power of negative 2. The answer is going to be 10 to the power of negative 14 minus negative 2 is going to be negative 12. So pH will be negative log 10 to the power of negative 12. It's going to be 12. So it is changed from 7 all the way to 12. So the pH has changed by 5 units. Now compare this 5 units with 0.02 units pH change. So that's how buffered solution works.